Okay, let's look at this problem. Before I discuss this problem, here's what I would like to request. So the problem that I'm trying is 1 plus 1 over x raised to power x. I would encourage you to try a variation of this problem. You don't have to work it out like from scratch. You can kind of just mentally do some work to see what would be different if I change this to say 1 plus 5 over x quantity, the whole thing raised to power x, or 1 minus say 3 over x raised to power x. So in other words, this constant can be positive or negative, can be any other different constant. What would be what would the result be different from the one that I'm trying to work on? So that would be a question that I pose for you to consider. If you get some time, absolutely you want to work that out. This is a very nice result. So now let's take a look at that. So I'm gonna, as suggested previously, you're gonna rewrite this into exponential form, right? So with base e, so e to the natural log 1 plus 1 over x raised to power x right here. So this power x, but you move this power x to the front. So I'm not going to write that. I'm going to write it here. And again, you can move this limit sign to the power. So I'm going to move the limits, apply the limits to the power here. X approaches infinity. I do forget one thing. I should actually check plugging infinity first, right? Do the substitution first. It will be 1 plus 1 over infinity, which will give you 0, raised to power infinity. You can see that this is actually like 1 to infinity type. This is one of the indeterminate form. So that's why we want to do this conversion. So once you do this conversion, check the form again. When you plug infinity, it will be infinity times natural log of 1, because 1 over x is just 0. Natural log of 1 is 0, so therefore we have infinity times 0 type. When you have that, you have to continue to convert. You cannot apply L'Hopital's rule for now. You have to continue to convert it into, so one of the 0 over 0 or infinity over infinity form. Here I would keep natural log on top. And why? Because I see 1 over x here. And if I do that, the bottom will be 1 over the 1 over x, right? I mean, x is 1 over the 1 over x. Therefore, 1 over x is on the bottom. So that's how I converted. This time, if you check, this will be 0. So it will be 0 over 0 type. Therefore, I can use L'Hopital's rule. So now I'm going to continue from here. So apply L'Hopital's rule. The derivative of the top, you have to apply chain rule. So natural log of u is your inside part. So natural log of u will give you 1 over u, which is, the u is 1 over 1 plus 1 over x. I mean, the u is 1 plus 1 over x. So 1 over the u times the derivative of inner, so the derivative of inner, right? So the derivative of 1 is 0. The derivative of 1 over x is going to be, you don't have to work it out, but I'm going to just go ahead and work it out. You don't have to, by the way, because you know you can cancel it, right? So over the derivative of the bottom is derivative of 1 over x, which is negative 1 over x squared. So I think I wrote this too huge, but this is supposed to be, the whole thing is supposed to be a power. But anyway, you can see that these two can cancel. Now we are left with only this part, Okay, time to plug in infinity into the power, and then you can see that it is equal to e to the 1 over 1 plus 1 over infinity is going to be 0, right? So therefore you get e to the power 1, which is e. How do you know this is correct or not? I encourage you to graph this function. So graph this guy in decimals, y equals that, right? And then at the same time, graph this function. So y equals e. Graph this horizontal line. Make sure that you see that the function is actually, this function actually approaching e. when x is approaching infinity. If you see that, that means you are correct. Again, make sure that you try some, follow my suggestion, try a few other problems, say 1 plus, say 5 over x, and then raised to the power x.